So we have been talking about, in these first 3 lessons of the chapter, we've been talking about different ways that we can solve quadratic equations, right? Those equations that have these squared involved. Does anyone, looking back at 9.1, what is the first way that we talked about that we can solve quadratic equations? Yeah, graphing is the first way that we talked about. So we said that if we have something, our quadratic equations look like this, that if we have an equation in this form, that we can solve and find the zeros by graphing and seeing where it crosses the x-axis. Now we can solve it and say x equals blank and blank based on where it crosses the x-axis. What way did we talk about yesterday for how we can solve these quadratic equations? What was that, Amari? Square root, which well, we've talked about factoring before, but we've kind of talked about solving. I can look at the official title. What do you mean? What? I shouldn't name it. But using our square roots, right? Just like Amari said. We can solve for these. Where's a good example? Here. Right? Now, the ones we looked at yesterday weren't in the form like this. Remember, we took out that middle term, so it's just ax squared plus c, some number on the end. But still, we use square roots in more of our algebraic skills to solve. Now, today, we're going to look at solving these quadratic equations with a third skill, a third strategy, and that's completing the square. Okay? Completing the square is our third strategy. So, our learning target, you'll be able to solve quadratic equations by completing the square. We have really just some terms and examples. We already did the review. Like I said, another method for solving quadratic equations is completing the square. In this method, a constant, or c, our last term, c, and we call that the constant because it's not being multiplied by x, right? This b value, or the middle value, will change depending on what x is. If I tell you that x equals 2, then that'll change what that middle term is. If I tell you that x is 7, that'll change what that middle term is. But no matter what x equals, this last value, c, will always be c. So that's why we call it a constant. But in this method, a constant c is added to the expression x squared plus bx. So that x squared plus bx plus c is a perfect square trinomial. Here's what they mean by that. We still are going to be working with equations that are in this form. Okay, just like we did yesterday. They're going to start out in this form. But then we are going to, through the process of completing the square, we are going to rewrite it so it looks like this. So it is in this form. And eventually, it'll be, we'll have some number here, it'll be in this form when it's all said and done. Okay? So we're starting out with the same type of equation or same type of form that we did yesterday, but now we're just going to solve it with a different strategy. So here are our steps to completing the square, and this will be helpful to write down. Your steps to completing the square. To complete the square for an expression in the form x squared plus bx, follow these steps. So again, we complete the square when we have something in this form, right here, x squared plus bx. First, find 1/2 of b, the coefficient of x. Well, I'll give you a second. Write down step 1, and then we will go through and look at this example. We'll go step by step through the example. So find 1/2 of b, the coefficient of x. So if we look at this example, the coefficient of x, or our b value, is 6. So 1/2 of b would be what? 3. All right, first step done. Find 1/2 of b. We did it. Square the result from step 1. So second step, square the result from step 1. So b divided by 2, we need to square. Last step, add the result from step 2 to x squared plus bx. Okay, so add the result to what we started with. So we started with x squared plus 6x. Now we need to add that result, plus 9. And then it really should have our fourth step here. I just circled in white on white paper, which makes sense. Our fourth step would be here. Factor the resulting expression as the square of a binomial. So then we want to factor this, which means we set up our 2 sets of parentheses. What multiplied together would give me positive 9, and add together to give 6. Yeah, positive 3. Since these are the same, we can write them in this form. So then if it said to solve, what would the x value, what would solve this? We want to find the x's. What would make this 0? Yeah, x equals -3. Good. If we want the, like it says down here, the algebra of all those steps, here it is. That might be a nice kind of summary to put at the bottom of those steps. So we take that b value divided by 2, square it, and rewrite our expression. Maybe about 10 more seconds to get that stuff done. Alright. We already did the first example. Let's look at another example. So our first step is to do, what's our first step? Yeah, and what's our b value? 9. Half of 9 is 4.5. What's our next step? Square it. 4.5 squared. I don't know what that is. Who's got a calculator? 20.25. 20.25. So we can rewrite it like this. Now, is this something that we can just factor in our mind? With that 20.25 on the end, that's kind of difficult. So what did they say in our shortcut here? We can just rewrite it as x plus b divided by 2, so that's 4.5 squared. So this 4.5, we can rewrite it as x plus b divided by 2, 4.5 squared. Now, if we were like writing this in simplest form and everything, we've never put a decimal right here, have we? We haven't done that before. So how would we rewrite this decimal in the fraction form? Well, as an improper fraction. So 4.5, 4 times 2 is 8, plus 1 is 9. Who remembers swooping? Swoop, there it is, right? We swoop the 2 to go underneath the 9. We just did a reverse swoop. Now, questions like this aren't going to come up in your homework a lot. I mean, this is more of a, I don't know if an extreme case is the right way to put it, but an unusual situation. Even if we don't come back to write it in this form, could we still see what the 0 would be looking here? X equals negative 4.5 would be our 0. So we don't have to keep going and write all of these steps here, but I just want to make you aware of what that would look like in simplest form if we were to completely clear it out. Let's look at another example. Here's also what we'll see. Solve that by completing the square. Now, this was one of our steps, but when they give us an equation that looks like this, where we have this negative 3 here and it's equal to 17 and all that kind of stuff, the first thing that we need to do is get the x squared plus 8x on a side by itself. So to get that on a side by itself, first we would need to add 3 to both sides. Okay, so we need to get that on the side by itself. Now we can complete the square. All right, so to complete the square, can anyone tell me what the end value would be here? What would our C value be? Take 8 and divide it by 2, so that would give us 4, and then we have to square 4, so that would give us 16. Now, whatever we do to this side, we also have to do to the other side. So we have to add 16. I mean, we can't just add this random 16 over here without doing it to both sides. So we also have to add 16 to 20. And that gives us 36. Right? Are we following? Now, how would we solve this? What do we think? How do we look to solve this? Because we completed the square, it said we had to solve by completing the square, so we had to do all this stuff. But where do we go from there? Okay, that's a super natural thing to look to do. So then you have this. Then what would we look to do? Yeah. Since we have negative 20 on the end, we need a plus and a minus, right? That's the only way to multiply and get a negative. What would be x plus what, x minus what? We need a positive 8 in the middle. What about x plus 10 minus 2? 10 times 2 would give us 20, right?
I forgot to
Are we following with this? good? Now, here's the direction. This is good. This is what we've talked about. Let me show you the direction that the textbook goes with it, okay? So here's where the textbook goes. They talk about how we can rewrite, I think you can see blue on here pretty good, yeah. How we can write this as x plus 4 times x plus 4 gives us, or equals 36. Right? 4 times 4 gives 16. 4 plus 4 gives us 8. So then that is the same as x plus 4 squared equals 36. Right? This is where the textbook goes with it. X plus 4 squared gives us 36, right? Then how did we solve this yesterday? Square root both sides. Then remember we talked about that plus and minus. Do we know what the square root of 36 is? Last step to get x by itself, we just subtract 4. So then our answers would be, positive 6 minus 4 would give us x equals 2. I can sneak it in at the bottom. 6 minus 4 gives us x equals 2. Negative 6 minus 4 gives us a negative 10. Is that the same x answers that we would get over here? Right? So either way works. This brings in more of what we talked about yesterday. And this is what we would be looking for today. Okay? This is what we would be looking to practice today. Now on a test, if this is the direction you go to solve it and the way that you show it, then I'm good with that. But either way, our first couple steps have to be the same. First, getting this over by itself is x squared plus 8x, and then by completing the square, going from there. Do I have any more examples? Nope. We've got a couple of practice problems.